Good morning, students. Today we are going to see the difference between inductive effect and electromagnetic effect. Inductive effect is a permanent polarization. In electromagnetic effect, it is the temporary polarization. Inductive effect operates through sigma bond, while electromagnetic effect operates through pi bond. Inductive effect is a weak effect since the sigma bond electrons are strongly held. Electromagnetic effect is strong effect because the loose pi electron shifts completely. In inductive effect, charge developed on the carbon joined to the substituent electron repelling or attracting is small and it is shown as del negative or del positive, which is shown in this formula. In electromagnetic effect, complete transfer of electron causes full charge on the carbon, which is shown by complete positive and complete negative. So just see here, when a reagent is added, electron is completely shifted on the right hand side of carbon. So complete negative charge is developed here, complete positive charge is developed here. Inductive effect can operate in saturated and unsaturated compound. Mesomeric effect operate in conjugated unsaturated compounds. Inductive effect involves electron of sigma bond. Mesomeric effect involves electrons of pi bond and lone pair. Now we are going to see hyperconjugation or no bond resonance. Hyperconjugation or no bond resonance is a special type of resonance which involves the overlapping of sigma orbital with a pi orbital. Hyperconjugation takes place in a following carbonium ion. Just see here, in this structure, this carbon have positive charge. So one can easily shift the bond between this carbon and hydrogen here. Because of that, this hydrogen got positive charge. So it is the transfer of sigma bonded electron. Since in a structure 2 there is a no bond between H plus and C, hyperconjugation is also referred as no bond resonance. The more hyperconjugation structure that can be written for a species, more stable. For example, in ethyl carbonium ion is stabilized by 3 hyperconjugation structure. So it is the ethyl carbonium ion. So one can shift this bond here. In second structure, this bond can be shifted here like this. In a third structure, this bond can be shifted here. The order of stability for hyperconjugation, tertiary butyl is more stable as compared to isopropyl carbocation, which is more stable as compared to ethyl carbocation, which is again more stable as compared to your methyl carbocation. The ortho and para-directing effect of methyl group is similarly attributed to electron release by hyperconjugation. So just see, this is the structure of toluene. So one can easily shift the bond between hydrogen and carbon in between carbon and carbon. Because of that, this cause positive charge, and the bond which are present here is shifted on this carbon, because of that it got negative charge. In similar manner, one can shift this bond here like this way. In general, resonance effect, that is mesomeric effect, are more important than hyperconjugation effect. The allyl and benzyl carbonium ions are more stable than most alkyl carbonium ions, because the former are stabilized by resonance while latter are stabilized by hyperconjugation. So just see here, this is the allyl example of allyl carbocation. So in this allyl carbocation, there are two possible structure. In a benzyl carbocation, there are four possible structure like this. Now we are going to see hydrogen bonding in organic compound. Hydrogen bonding is an attracting force which occurs in any compound whose molecules contain OH or NH bonds, as in water and in alcohol, acid, amines and amides. The OH bond is highly polar bonds. Oxygen is more electronegative than hydrogen and pulls the bonding electron closer to it. As a result, this displacement, the oxygen atoms acquire small negative charge, that is del negative, and hydrogen atoms got a small positive charge, that is del positive. So ROH, just see in this formula, this oxygen got del negative because oxygen is more electronegative than your hydrogen, and because of that hydrogen got del positive. It can be shown like this or like this. The adjacent molecule of a compound containing OH bond will attract it to each other by virtue of these opposite charges. This force of attraction is known as hydrogen bond. Usually hydrogen bond is represented by dotted lines. So just see here, this is one of the molecule of alcohol, it is another molecule of alcohol. So just see here, hydrogen have del positive charge while oxygen of this molecule got del negative charge. So these two charges are opposite in nature. So there is attraction taking place, and this type of attraction is generally known as hydrogen bond. Hydrogen bonds is of two types. Intermolecular hydrogen bond. First type is intermolecular hydrogen bond. Intermolecular hydrogen bond is formed between the, it is important, it is formed between the atoms of two or more molecules, resulting in the association of molecules. For example, water and alcohols are associated as a polymeric aggregates in liquid and solid state, whereas carboxylic acid and amides exist as dimer in a liquid and gaseous phase due to the intermolecular bonding. So just see, in this case, this is one molecule of acid, while this is second molecule of acid. So in this case, just see, this hydrogen from this molecule is get attracted towards this oxygen, while this hydrogen from this molecule is attracted towards this oxygen. So this type of bonding is simply known as intermolecular hydrogen bonding. Dimeric, it is the dimeric form of carboxylic acid. Now we are going to see intramolecular hydrogen bonding. Intramolecular hydrogen bonding is formed between two atoms within the same molecule. This result in the formation of 5 or 6 membered ring, that is chelate ring. So just see the example of orthonitrophenol. In orthonitrophenol, just see this compound have nitro group as well as your phenolic OH group. So this hydrogen from phenolic OH, it is also attracted towards the oxygen of your nitro group. So this is a type of hydrogen bonding which are taking place within a molecule. It is known as intramolecular hydrogen bonding. Same thing is happening in orthofluorophenol as well as salicylaldehyde. Now we are going to discuss effect of hydrogen bonding. So first effect, it is on a boiling point. Just see the boiling point of propane, it is minus 45 degrees centigrade. Boiling point of dimethyl ether is minus 25 degree centigrade. While boiling point of ethyl alcohol, just see it is 78 degree centigrade. So in a propane there is no hydrogen bonding. So boiling point is very less. Same thing with dimethyl ether. But in ethyl alcohol there is intermolecular hydrogen bonding takes place. That's why boiling point is increases. In simple language we can say that due to the hydrogen bonding, boiling point of the compounds increases. Now second effect is effect on water solubility. A hydrogen bonded substance is usually soluble in another hydrogen bonded substance. For example, alcohols are soluble in water but alkane not. This is because a non-polar alkane molecule cannot break into the hydrogen bonded sequence in water. It cannot replace the hydrogen bond that would have to be broken to let in it. So just see, this is the water molecule and dot show hydrogen bond in between oxygen and hydrogen. So in alkane there is no hydrogen bond. That's why alkanes are not able to break this hydrogen bond. And that's why alkanes are not soluble in water. It cannot replace this hydrogen bond because it don't contain a hydrogen bond. Non-polar alkane molecule cannot slip into the hydrogen bonded sequence. Now just see the example of alcohol. What happens when we take alcohol in a water? An alcohol molecule is capable of hydrogen bonding. It can slip into the hydrogen bonded sequence in a water. It can replace the hydrogen bond that must be broken to let in. Just see, this is the water molecule which are already have hydrogen bond in between this hydrogen and oxygen. Alcohol molecule is a capable. Alcohol molecule also have a hydrogen bond. So because of that, this alcohol molecule is capable to replace this hydrogen bond and form new hydrogen bond with the oxygen of alcohol. So just see in this diagram, the hydrogen bond between two water molecule is now replaced with hydrogen bond of alcohol molecule and oxygen atom of your water. In our next class, we are going to see mechanism of organic reaction. Thank you very much.